This is the first lecture on control engineering. So let's have an introductory session on this. So basically we are looking at controlling different systems. And when you look at the different industries like automotive industries or aerospace industries, the projects that they do are very complex, and hence these need to be divided into many smaller systems. So the first thing we need to look at is what is a system, because that is what we would be controlling. So control engineering, or it can also be called as control systems. So basically we will be controlling the different mechanical and electrical systems. So let's take an example of a braking system. So basically a braking system would consist of the brake assembly. So the first thing that it would consist of is the brake assembly. The second thing that it would consist of is the hydraulic system, which would apply the pressure for engaging the brake. Hydraulic system. The third would be the parking brake, which is different from this other brake. Parking brake, and the lighting system, and the lights which appear when you apply the brakes. So you have the light system, and then we have this ABS to avoid skidding, of the vehicle when you apply a sudden brake to the vehicle. So all these four uh, brake assembly, the hydraulic system, the parking brake, and the light system, the ABS. So all these can be individually called as a system, or you can call this entirely as a braking system and call each assembly as a subsystem. So either you can call this braking system as a whole system and then call these each as a subsystem, so that the work can be divided among the group of employees to work on each particular thing, so that there is a specialization. So a group specializes on the brake assembly, another team specializes on the hydraulic system, there will be another team which works only on the parking brake, there may be another team which works only on the ABS. So each part is done by different teams in the industry, and all these can be thought of as subsystems, and the whole thing as braking system. But the other way to look at is each is a system. The brake assembly is a system, hydraulic assembly is a system, the parking brake and this light is a system, ABS is also a system. So all these systems and the other parts of the automobile in combine, the car can be considered as a system. So what is considered as a system and what is considered as a subsystem, that depends from the problem to problem or the company to company. So how it looks at each system. So basically we need to understand that the one which we would like to control, we would consider it as a system. In this course, the control engineering course, what we refer to the system would be the one which we would like to control. So when we have a system is represented by a rectangular block. So this is a system and it will have an input and it will have an output. So it's not necessary that it has only single input and single output. There can be multiple inputs, there can be multiple outputs. So we will initially look at single inputs and single output systems, because to avoid the complexity of the systems. So we will look at SISO. It's called as SISO. SISO stands for single input, single output. So you have studied mechanical systems when you have undergone this mechanical vibrations course, where you looked at mechanical systems, for example, an automobile, a bike, for example, a person riding a bike. So you have done the mathematical modeling, that is the modeling into the spring mass and the damper systems, so which you have undergone the course in the last semester. So you are aware of how to model a mechanical system. but it might become complex when the system is complex. So it's simple to have a spring mass and a damper, or two mass or two dampers, two springs. So you can model it based on the system, but when it gets complex, it's difficult to do it based on the physics. So basically what I'm trying to tell you is you need to identify the system. So before controlling a system the way we want it to be, so you need to identify a system. So basically, if in a company, a product like, for example, um, a hair dryer is given, okay, and you want to have a control system for this. So for that, you have two methods. One is the white box method, and the second method is called as the black box. The second method is called as a black box. So in white box method, you use the concept of physics. Suppose you have an input. This is the system, and this is the output. So you have to find out what the system is actually. So you cannot have text or an image and solve a problem. You need to have a mathematical model. So suppose if a hair dryer is given for a feedback control, you need to have a feedback control in a hair dryer. Then you need to understand that hair dryer system and write a mathematical model for it. So writing a mathematical model is important. So mathematical model writing for every system becomes a complex one if you go with the physics concepts. So you may not be aware, or it would be difficult to apply the concept of physics for a complex system. So in that in that case, what you do is you use the black box method and take the data approach. Using the data of the input and output, you find out what the system is. Suppose take the example of hair dryer again. If you know the power that you supply to the hair dryer, and if you find out what is the temperature for say 3 watts, 5 watts, 10 watts, and what is the corresponding temperature, suppose this is 35 degrees centigrade. I'm just giving some example here, say 40 degrees centigrade, and say this is some 50 degrees centigrade. So you have the input and you have the output. So you need to find a mathematical model and identify the system. So this is called as the black box method, where you are not aware of what kind of system it is, but with the help of input and the output of this data is obtained experimentally. So you have conducted an experiment, you have varied the power, you have measured the temperature, and you're trying to identify the system here. So there are three things here. So you have the input, you have the output. So you know the input and the output, and so you are able to identify the kind of system it is by a process called as system identification. So basically it is of two methods. First one is you understand the system by its physics. For example, a spring mass and a damper, you understand the physics easily. But if it's a complex system, it would be difficult to apply the physics, and that's why you use the data approach method, where you have where you conduct an experiment on the system, you give some input and find out what are the outputs that you get, find a relation between this input and the output, and find out what this system is about, define a mathematical model for the system, and then you have the system identified. So that is a system identification problem. So second one is a simulation problem. Simulation problem. This is where you know the input, you are aware of the input, and you know what system it is. You have the mathematical model, and you are trying to determine what is the output of this. So, so with known inputs, with a known mathematical model, what is the output of this? So this is called as a simulation problem. The third type would be the control problem. In this, you have the system, and you know what is the output that you need, but you need to identify what input should be given to get that particular output. So this is a control problem. So this is what we would be basically working on the whole of this semester. You know what is the desired output that you need. You know the mathematical model of the system, and what should be the input that you need to give in to get the corresponding output. So this is the control problem. So the first one was system identification. Second one is simulation problem. Third one is control problem. So all these three we will work on, and mostly we will largely we will work on the control problem. So why do we need, when we talk about control systems, we talk about feedback. So you know, you are aware of the open loop control system and a closed loop control system. So why do we need feedback or make the control system a closed loop? So the reason for this is, if we go with open loop systems, it is basically suitable for simple processes that have well-defined input to output behaviors. So if you want to develop only a simple system which is having well-defined input and output, then it is fine. But for example, a dishwasher. So how much time the dishwasher should run, you decide and then set it up. So without getting the feedback of how much clean it is becoming, so just based on the time it works, 10 minutes, 15 minutes. So whatever the setting time is given, whatever the time that you set in the dishwasher, till the time the dishwasher runs and it cleans. So it doesn't take any feedback of how much clean it is happening. So you don't have any feedback in that. So these are open loop control systems. But open loop control systems are not sufficient for all in all cases, because there are disturbances. Feedback is required because the main reason to have feedback is because there are disturbances. These disturbances do not allow to get the required output. So since there are disturbances, the feedback becomes important. So basically we'll define what a control system is. A control system, we define what a system is. So a control system is a mechanism that alters the behavior, or the future state of a system, or the future state of a system. So what you're basically doing is you're having a mechanism that alters the behavior, so it overcomes the disturbances and gets the required output. So it alters that behavior. So if this was an open loop system, it doesn't overcome the disturbances, and the output may be different than the required output. So if we have a mechanism that alters that behavior and overcomes the disturbances, then it is actually altering the future state of a system. So this is the importance of a feedback control system, basically to overcome these disturbances during operation, and which we cannot plan for. In an open loop control system, we cannot plan for these disturbances, and these disturbances has to be overcome only during the working. So a feedback control system becomes important, and this is what we will be focusing on throughout this semester in this course. So basically it is going to be mathematical, because we will be using the mathematical modeling. So either the white box approach or the black box approach. So we'll do both methods for the system identification, and then see what are the techniques that are available to develop a good feedback control system. We'll be using MATLAB along with the course to have a good hands-on on MATLAB, as well as to simplify and easily understand the concepts of the control system. Thank you.